All right, example 1 says find the derivative of f of x equals the square root of x squared plus 1, and we're going to be using the chain rule. This is actually the problem we started out with in our introduction. So the first thing I would do is figure out who the outside is and the inside. Okay. So I always write down the outside and the inside. And we'll move away from this, but this is kind of a good way to get started until you feel comfortable with the chain rule. So I always say, who's the inside? X squared plus 1. Then the outside is, who did you plug x squared plus 1 into? Square root of x. And try and do composition. If you take the inside and plug it in here, you should see that it goes back to the original function we were given. Now what we're going to do is take the derivative of each one of these. Okay, so taking the derivative. This is really x to the 1/2. So when I take the derivative, I would have 1/2 x to the negative 1/2. And now when I take the derivative of my inside, it would be 2x, and the derivative of 1 is 0. Okay, by taking our derivative. Now from here, I'm going to go ahead and write my chain rule down. Okay. F prime of x, my derivative of the original, is the derivative of my outside, which is right here, with the original inside plugged back in. So I take the original inside and plug it back in. Okay, so I would have 1/2 x squared plus 1 to the negative 1/2. And then you multiply it by the derivative of the inside, which is right here. So times 2x. Okay. Now from here, I would do a little simplifying. I would have 1/2 times 2. So those will cancel. And then this is a negative power, so I would put it in the denominator. And this is really x to the first, so I'll be in the numerator. So I will have x all over x squared plus 1 to the 1/2. And I would probably rewrite that. If you have something to the 1/2 power, it's really the square root of x squared plus 1. Okay, and remember, now we're in calculus, you don't need to go ahead and rationalize that. You can leave your answer as is. So there is my first derivative using the chain rule.